Geohazards are the result of natural, active, physical processes. Probably everyone can list a range of geohazards, such as volcanic eruptions, earthquakes, tsunamis, landslides, rockfalls, avalanches, floods, and droughts. Millions of people worldwide live in areas that are endangered by geohazards. A prominent example would be settlement in the vicinity or even on the slopes of a volcano, as often the soil is very fertile and well suited for agriculture. Here you can see an example of agriculture at Sinabung volcano, Indonesia. Geohazards can also occur in a wide range of sizes. Small-scale occurrences typically have less impact on population, infrastructure, and environment, but still should not be underestimated. The area of geosciences has gotten increased attention in the last years, especially in the light of climate change. Extreme meteorological events, such as strong precipitation, are hypothesized to increase in the following decades, which in itself can already be classified as hazardous, but might cause secondary hazards such as floods or landslides. According to the World Bank, since 1980, 2.4 million people died and more than $3.7 trillion have been lost due to disasters caused by geohazards. Statistically, the likelihood of being affected by geohazards is also a social question. Of all deaths from weather, climate, and water hazards, 91% occurred in countries defined by United Nations as developing economies from 1917 through 2019. The social, economical, and environmental impact of the actual occurrence of a hazard is one of the main motivations for conducting scientific research in the geohazard area. Another reason is, as with all other research areas, scientific interest and curiosity to learn about, understand, and classify the processes in our environment. Over the last decades, research has been conducted, methods developed, and much knowledge acquired. Fieldwork has been conducted to assess the distribution of historic events. Models have been developed to describe, predict, and assess the different geohazards. These models cover the whole spectrum of possible approaches: physical models, data-driven models, statistical models, heuristic models, and so on. The development is far from being over. Every year, many publications are being presented, applying new methods, presenting new approaches, or investigating previously neglected regions. It is a very active and interdisciplinary field of research with a direct practical application.